Okay, so now we're going to talk about complex numbers in powers, also known as de Moivre's theorem. I'm probably saying that wrong, but it's okay. So, what if I needed to raise a complex number such as 1 plus I raised to the eighth? Okay, I got two options. So, first option is I could expand my binomial and multiply out. Okay, so I would actually have to write out 1 plus I times 1 plus I times 1 plus I, 1 plus I. So that's 4, 5, 6, 7, and 8. Okay, I would have to write that 8 times out, and then I would have to distribute a lot. Let's say I don't want to do that. So I would use something called de Moivre's theorem. Okay, so what de Moivre did is he said, well, I have this really cool way of multiplying complex numbers if they're in polar form, so why don't I just, do kind of the same thing, but with repeated multiplication. So first thing you got to do is convert the complex number a plus bi to polar form. Okay, then you apply the formula. Okay, which is z raised to the nth power is equivalent to r raised to the nth power cosine n theta plus I sine n theta. So whatever power you're raising your complex number to, you're going to multiply your angle by that. Okay, so let's try it. Okay, so 1 plus I to the eighth. Okay, so first I need to convert. So r would be square root 2 theta, and I'm going to do this super fast. So that would be pi over 4 because we are in quadrant 1. Remember, you always have to ask yourself where you live. Okay, and then tangent of theta is 1, so that would happen at pi over 4. Again, I did that super fast, so if we need to review that, we can. So now I'm ready to hop into my formula. Okay, so using our formula, and we're just plugging it in. Okay, so radical 2 raised to the 8th is the same thing as 2 raised to the 4th. Okay, which would be, that's not a 24, that's 2 raised to the 4th. 8 times pi over 4 would be the same as 2 pi. So 2 to the 4th is 16. Cosine of 2 pi is 1. Sine of 2 pi is 0. So my answer is 16. Now, believe it or not, that is way easier than multiplying it out 8 times. Okay? All right, let's do another one. And then, okay. All right, so let's take and make our z 1 plus square root 3i raised to the 12th. Okay, so first convert. So r would be 1 squared plus radical 3 squared. So that would be 1 plus 3, which would be square root of 4, which is 2. Hey, that's not so bad. All right, now let's work on, okay, let's work on, let's see, oh, tangent theta. Okay, we're going to do b over a. Oh, I have to know what quadrant I live in. So again, this is quadrant 1. Okay, so theta would be 60 degrees, or I would do pi over 3. Okay, this does work in degrees or radians. I just find the radian measure a little bit easier to work with. Okay, so we have our r, we have our theta. Now we're ready to put it into our formula. Okay, so I like that, and then we do, here's our r, cosine pi over 3 plus I sine pi over 3, and we're going to raise that to the 12th power. Okay, here we go. So 2 to the 12th. Might have to get my calculator out for that. And then cosine 12 times pi over 3 plus I sine 12 times pi over 3. Okay, so 2 to the 12th, I know what that is. That is 4,096. Okay, 12 times pi over 3 would be cosine 4 pi, I sine 4 pi. Now, 4 pi I know is not on the unit circle, but if you subtract 2 pi, that is coterminal to 2 pi. Okay? So that's 1 plus I times 0. I must like that number today. So my answer would be 4,096. Okay? So, yeah, this is a fairly useful formula because we do sometimes want to raise complex numbers to powers that we don't want to multiply out. And it's way faster than actually multiplying it out. Okay? So next up is roots. And hope you're having a good day.